take with digital cameras, they're pixels, they're things that you see on your display monitors. So they come in little, each pixel is called the top, not necessarily a title, let's just call them pixels. And then each pixel has 3 different values. For example, if we have a RGB monitor, there's a value for RGB, and they are stored in this cell. Okay, so these are called raster types. Otherwise, we have the vectors. Okay, vectors came first, and then raster was added about 3-4 years ago.
So this is like an image thing?
Yes, this is like an image thing. We'll show. Yeah, we'll show you. This is more mathematical. So if you need to model something with vectors, yes, do that. Highways, your house, where it sits on the lot. That's all. Try to do vectors. That's going to be quicker. But if you have no choice, you gotta. We'll show you a picture. You take a picture of a dog. You kind of have to do rasters. All right. So we got the subway line. So what I like to do is, once I have data, I want to visualize it. And there are 2 popular tools for just visualizing the data. And one of them is OpenJump, and one of them is Quantum GIS. I'm going to just show you Quantum GIS for this very first part. Okay. Of the 2, Quantum GIS versus OpenJump. Quantum GIS is the one that's the one that takes forever to install. You need to restart your computer. It takes forever to load. OpenJump is much quicker. However, it requires that you have Java runtime already installed. So there's your trade-off. They all have features. They have a lot of features that we don't even know about. But they have different features. OpenJump is by far the leaner one to use. But Quantum GIS certainly has amazing things. Like, look at all those icons. All right, so let me try to look at what I look at these subway lines. So I go to layers, add a PostGIS layer. And I'm going to connect to my database. And I believe I'm loading it here. And I'm going to put in nodes. Okay, so that's our subway line. Kind of makes sense. I did not bother to create a base layer of Boston because we all know that that looks like the Boston subway system, right? Yeah, see, those, okay. There's a silver line in here. That may be confusing you. Okay, some people have called it the silver lie because it's not really a subway. Yeah, so that's what accounts for all these things that they're calling a subway. This is, but here's your blue line, here's your orange line, here's your red line going to LY, here's your green D line, and so on. All right, so this is right, more or less. Okay, and okay, so this lets you see the data. Now, suppose that I want to ask the question, well, we are here at 1 Sharp Place, also known as 250 Washington Street. This building has 2 addresses. And 250 Washington Street is the Department of Public Health, which occupies the first 9 floors. I want to ask, well, what station am I closest to? So I can write a query. And I use my geocode function. And I'm going to take the result of this and stick it into a 10 table. All right, so this is the address. Run that. Let me just delete my temp table. Create again. Okay. So
Is that getting the Tiger data for where 250 Washington Street is?
yes. So once it will look at the Tiger data, which Tiger, by the way, is the definitive source for all streets in the United States. There are proprietary sources, but they all originate from Tiger in the sense that nobody's going to go out there and resurvey the country for you. So everything comes from Tiger, which is the U.S. Department of something. Census. So they have all the geometries of the streets and lakes and streams and all that stuff. So that's the definitive source. So let's take a look at what we got here. So I created a new table, and it should just have one row for now. It gives you a rating depending on how well it geocoded. A 0 means an exact match. All right? And the geometry, which you cannot read in this presentation, is a latitude, longitude. And I'll show you how you can read that. I will show that as text. Okay, and it is a point at -71 longitude and 42 latitude. Okay, so that's where we are right now. Now, so I want to, before I can compare this to the mass plane, which is in a different SRID, I have to transform this because longitude, latitude, long lat, that's got EPSG of 43.26. Okay, so to do comparison, I have to either take mass plane, convert it to this, or go the other way. So I'm going to go the other way. I'm going to convert this to mass state plane. And let me see, the SQL for that is simply, I'm going to update it using the ST transform function. And the second argument is the new SRID. All right. So, run this query. Okay, so that one will affect it, and let me show you the results. The textual representation. And if you recall from the quick QGIS, those coordinates were in the 20,000. So we should expect to see something along that range instead of -71. Yeah, I already transformed it, but this will, see now our point from latitude, longitude to latitude is in the 236,900, which matches closer with what we have in QGIS. Here in QGIS, if you look down here, it's showing you the coordinate, and actually I can add this point to my map. Connect public point here. Get this. And then add. Oh, there's my point. And if you zoom in, here we are. Okay. So we all know that's State Street Station. This is Downtown Crossing, this is Government Center, and this is Park Street. And we are right here. Okay. So now that we have them in the same SRID, I can start writing proximity queries that ask how close is something to something, which you will find to be the most common use. Probably more than 50% of the times you're asking a question about how close something is to something. There's hundreds more functions that goes beyond that, but we're just going to cover the distance functions. By the way, we wrote this book, and this is the first edition. The second edition is in the works. So I'm offering this for 50% off the cover price, and I'm open to negotiation. And this will tell you all the other 100 or so functions, and then for the rest, there's always the manual, the official PostGIS manual that you can refer to. Oh, we wrote a PostgreSQL book as well. Second edition on this as well, so 50% off of this. I'll take cash and check. If you want to give me your credit card number, that's also okay. All right, so we have transformed this. Now let me just ask, what are the closest stations to me? So I'm going to do a join of my temp table. To the MBTA nodes, meaning the stations. And we run that, and this is ordering by the distance closest first. Okay, it makes sense. The distance 105, that would be in meters because massing planes in meters. So you're 105 meters to, if you're thinking about which subway station to hit, it'd be state, and then government center and so forth. All right, so now you can take a point and compare distance with another point and order it. You can probably still do this with a non-PostGIS database. Just get the point data and do your do that trigonometry formulation. Yeah, and get the distance. So I'm going to go on to.
I have a question. How would it work if your temp had more than one point in it?
It would create duplicates that you would then use distinct and so on to filter out.
Because what you could do is if your temp had a location, you could list that in the select, and then you would have for each record that it goes with that record.
Okay, so the next example, we pulled the bus routes for Boston. And I'm not going to show you the loading of the data, but it's the same idea. I look at the data. These are the bus numbers that you see on top of the bus, and local express and route description. And the geometry is a line string. Very long line string that has segments for each the little pieces of where the bus goes.
Yeah,
So,
usually if it's long, the PGIS doesn't show it. It's blank. So that simplifies it to huge geometry.
okay, and we can look at this in QGIS. Let me close this, discard. This is other things here. The layer and let's just layer. All right, that's the bus routes. I'm zooming in. And let me zoom into a level where I can actually add the route numbers. Setting, view. I want to shoot.
I think if you right click on layer,
The label here somewhere.
yeah, I think if you right click on the layer,
Properties.
properties. specify the field. Field containing label.
Bus route nature. Okay, so those are the bus routes in Boston, Greater Boston. So now I can ask questions, and I just want to show you some of the functions that's available. I want, what are the shortest routes in Boston? Okay. I take the length of the geometry, and remember that the bus routes actually, they're not a single big line string. Line strings have little segments. So we actually sum the length of all these segments that constitute the bus route. And then we will order it by the second, which is the length, giving us the shortest bus route first. So bus routes 146.